Before we jump into day 5, I want to quickly demonstrate Clojure's immutable collections. Specifically, if we define a linked list and look at the linked list, then it contains 3 items. If we peek at the very first item, then we get the very first item. If we pop the first item, we get a new list with the first item missing, but it's a new list, so the old list still contains all the items. And if we add another item to the list, that goes on the front, but still the original list hasn't changed. So think of linked lists like Java strings. You can't change Java strings, you can only produce new, slightly different strings. Okay, then on to the actual topic. So we are given, basically, let's say an array of stacks. In the example, there are 3 stacks numbered from 1 to 3. I added another empty stack just so I don't get confused with 0. So this is stack number 0, which is never accessed. Okay, and here you can see the elements on the stack, and I, simply used linked lists for that, and I already pre-parsed this by hand, basically. I didn't bother to write a parser. And the top element is at the front. That's where linked lists are efficient to access. Okay, and the moves, I also pre-parsed them with Visual Studio multi-cursor editing. So here is the moves parsed. How many do we want to move from where to where? Okay, now the first function that we're going to write, what does it do? So it is given an array or a vector of stacks, and then the information, how many do you want to move from where to where? So basically one of those vectors. And what's the example here? We want to move 2 elements from 0 to 1. So first the A is moved over, and then the B is moved over. And so they reverse their order, basically. Okay, so how are we going to do this? Let's see. So depending on n, we have to do that multiple times. So let's use a good old loop construct where we say, maybe let's call the source the stacks at from, and target is stacks at to. Okay, so vectors are functions of their indices, similar to maps. And then n is the n that is passed in, and we're going to decrement it later. Okay, and then we have to check if n is still positive. If it is positive, we have to actually transfer an element. How would we transfer an element? Yeah, we would basically recur. Recur is basically a go-to back to the loop, and we have to provide new values for source, target, and n. So the new value for source would be pop of source, because we want to remove one element. For target would be const target and then the new element. That would be peak of source. Remember that this doesn't change the source, so this is still the right top element. And the n must be decremented, right? Okay. Great. And then otherwise, when we're done, we have to put the new source and target back into the stacks vector. So that would be a source stacks and then index and value. That would be from source to target. Okay, let's see if that works. Yeah, that already works. So I think a quite simple solution, not too complicated. Okay, so then let's look at the next function, the actual part 1. What do we have to do here? Yeah, so we're given the stacks and the moves from above, the examples, and then we have to look at the very end, the items that are on the top of the stack. Okay, let's see. So basically, we want to start with the stacks and then call move 1 with the stacks inserted here, and then the very first move, right? That would be moves at 0. What would that do? That would basically put the D from here to here. And then we want to do that again for all the other moves. And that already looks quite good. So here's the C that we expect, the M that we expect, and the Z that we expect. That's quite nice. But of course, it's quite tedious to write all of this stuff out. So there is already a function built in that can do that for us. That's the reduce function. And the reduce function takes a function, a value, and a collection. The function is the function move1 that we want to apply. The value is our stacks, and the collection is our moves. So this will have the exact same effect as this guy. And in case you're not familiar with this threading macro, we can macro expand this form, and then you can see first we call move1 stacks with move0, then we get a new stack, we call move1 on that again with moves1, then we get a new stack, then we call move1 on that with moves2, and then we call move1 on that again with moves3. But of course this is much more readable. Okay, but the reduce is even better. Does that work? Yeah, it gives us the same result. So now we have to go over all the elements and look at the very first element on those stacks. So that would be, let's do that with another threading. That would be map peak. Here, then we get nil for the empty stack and then CMZ. And we can simply pass these four elements as individual arguments to the str function with apply str. And then we get the correct result. That's quite nice. Not too complicated. Okay, let me copy paste this guy for move 2. So what's different now for move 2? Note that the A and B previously changed their order to BA, and now the A and B remain as A and B. Okay, so the best solution that I came up with was, let's work with a temporary stack that is initially empty. This is an empty list. Then we have to conj onto that guy, of course. And then at the end, when we are done, we want to put all the temporary elements onto the target. And then we will reverse twice and cancel out the reversal. So that would be into, what is our target? That is stacks to. And then here our source collection is temp. And that also works. Yeah, so into is a quite nice function. Simply, we have an existing collection and we want to put all of these elements also into it via repeated calls to conj. Okay, cool. And then let me copy paste this guy down here for the actual part 2. Of course, we have to change the move 1 to a move 2. And then the tests also pass. Yeah, and this thread macro is similar. So if we macro expand this guy, then yeah, we can see it here. So we started with reduce move to stacks move. That was the very first form that we passed in. The result of that was then inserted here at the very last position, map peak. And the result of that was then inserted here as a very last argument, apply str.